Ready? Awesome. All right, guys. My name's Jessie Morris, and I'm going to be talking a little bit about testing, continuous deployment, and building your projects. So why continuous deployment? Well, it's pretty awesome because having an automated system in place for testing and deploying a project makes it really easy to make sure that you didn't break shit as you were doing things. In order to test a project and have a good continuous deployment in place, obviously you have to have tests. Without tests, your continuous deployment doesn't really do you a whole lot of good because you can just deploy broken stuff all the time. Generally, you want it triggered by a post-commit hook, so that way as soon as you push something to GitHub or wherever your Git repo is, or Subversion or what have you, hopefully not Subversion anymore, but then it automatically causes a build to happen. You run tests, and potentially, if everything looks good, have it automatically be deployed. Tests. There are lots and lots of different options for tests. I mean, every single language has about a bajillion different ways to write tests. There's integration level tests, which generally consist of, actually driving the UI and seeing, when I click this button, does this form pop up? And when I type stuff in this form, does it actually get saved to the database? So generally, with integration level tests, you're actually making use of either the API or the UI directly. You also have unit tests, which I'm guessing most of you are familiar with. For JavaScript, we've got Mocha, Jasmine, QUnit. Those are kind of the three big ones right now, I think. Mocha seems to be gaining a lot of popularity lately. And then performance tests, which, as we all know, healthcare.gov kind of could have used a little bit more of this. Obviously, it's important to know, did my commit make it 10 times faster, 10 times slower? Are we going to be able to scale still and handle the volume that we have currently? Or is it actually going to break everything because, page response time go from 50 milliseconds to 50 seconds? Having these different tests can help prevent regressions. They can ensure code quality, and potentially if your tests are good enough and if you have confidence in your testing, you could automatically deploy, make sure that things are stable via your tests, and then have things automatically deploy, so you're not waiting on someone to click a button or whatnot. Any questions so far?
Yeah.
Yeah.
Which unit test do you prefer? I was using Karma for a little bit, but I don't know.
Mostly, I've been using Mocha. We also have some Jasmine. The tests that I'm going to be showing today are mostly written in Jasmine. We also make heavy use of Selenium. There's not really any other great options for testing browsers and actually doing integration level testing. There are some things like Casper.js and some other headless type options, but not a whole heck of a lot. Selenium's kind of your best bet on integration level. Performance tests, there's a bunch of different tools, AB, Apache Benchmark, Siege. Generally, they interact with the API directly instead of with the UI or whatnot. It's kind of hard to spin up 100,000 browsers and drive them all, whereas it's a whole heck of a lot easier to spin up 100,000 HTTP connections. Anything else?
Are you using anything for browser versions?
So there are a couple of different services out there that exist. There's Sauce Labs, Browser Stack, or not Browser Stack? I don't know, something like that. They all kind of suck. Because they're all done via the cloud, it means that they shut down your VM every time, and then when you want to run a test on Windows or whatnot, they spin up the virtual machine and then run your tests, and you get all of this They might spin up your virtual machine.
They spin up a Linux virtual machine to then spin up a Windows virtual machine.
Basically. So you get a lot of latency with that kind of stuff. Selenium by default kind of has a lot of version stuff baked in. There's a product called Selenium Grid that basically handles, you create some hubs, they call them, that have different versions of the browsers installed on. Probably install Caffeine at some point here. Whoops. So you can install or have these different hubs, and then when you say, I need to do a test against this browser with this version on this operating system, so you can specify, IE8 on Windows XP if you're a masochist, but hopefully not. So Selenium by default has that kind of stuff. It's a lot better than like the browser stacks and Sauce Labs of the world, just due to the latency. So, all right.
Right now we're using Sauce Labs and hating everything.
Yes.
And it costs. I mean,
Yes, it's somewhat expensive. Browser Stack's a little bit more expensive. They charge you by minute, basically. And if you want to test a lot of things on OS X, it's actually quite expensive because they can't really virtualize OS X except on OS X machines due to licenses and whatnot. So continuous deployment, there's kind of the three big tenets of it. Having an automated build process, so taking your code and munging it into whatever you're going to send out the door. So for a lot of production sites, it includes minifying your JavaScript, CSS, HTML, compiling it, taking your Jade templates or whatever and converting those into HTML, all of those different things. And then once you have it, compiled or built or whatever, you take that and then you run your tests against it, both integration, unit tests, performance tests, whatever you have to make sure that this build is good and solid and ready to be deployed. And then once that happens, depending on the process that your company's decided on or you've decided on, you can either have it automatically be deployed, have someone have to push a button so that way the sales and business people can say, hey customers, look what we just deployed, stuff like that. So either way. And that's kind of the end of my presentation. So now I've got some examples of what we've done recently at Jive regarding our continuous deployment and testing. So we have the public repo out here, the Jive.js Commons repo. And it has, we use make for our build. I know a lot of people are kind of partial to Grunt or Cake or whatever. We use make because it's been around since like 1977, so pretty well tested, pretty robust. We know it works and we know how to use it. So
Also, we can install, Mongo, Node,
yeah,
whatnot on.
as well as with our Chrome apps that we bundle for OS X and Windows and Linux that people can actually install. Having a make file that actually takes that code, compiles the C code into an executable, uploads it to an FTP server or whatever, however we're going to do that. I feel like that's a lot easier in make since it's language agnostic, whereas things like Grunt are kind of more specifically for JavaScript. So that's kind of why make. How many of you guys are familiar with make files and the syntax thereof? Awesome, that's good. I'll just kind of go over it real quick. So with make, you have these different things called rules. Basically, rules are just names of things that you want to do. You can have phony rules, which basically mean that they don't depend on an actual file, that they're just kind of like these fake things for convenience.
It means they also don't generate a file.
Yes, that's also true.
That rule.
Yes. So here we have all, build, clean, test browser, and watch. Now, the interesting thing about make is the first target that you have in your file is the one that gets run by default. So here we have the all target, and it just depends on build. So it's basically a way to just run make, and it will automatically run build if you're lazy. Here we set up some environment variables. We get what platform you're on, whether it's OS X, Windows, or Linux. We have some uglify flags based off of which environment we're currently in. So if we're in development, then we actually don't want to minify our code, and we actually want to beautify it. That's what the -b means. Here we do some dependency checking. So we look to see, do you have npm installed? Yes, okay. Do you have uglify.js installed? Okay, that's good. And then here's where we set up some of our dependencies. So the Jive.js file actually depends on all of these different files. So anytime one of the dependent files changes, we actually rebuild the Jive.js file. And let's see here. Here you can see where we actually install a dependency if we don't have it. So if we're on Darwin, then we go ahead and do brew install node. Since we're deploying generally on CentOS, right now we're just kind of lazy, and otherwise, just go ahead and use yum. We could do a lot more detection there about being intelligent, installing it using apt if it's Ubuntu or Debian, yum, using CentOS or Red Hat. Windows tell you to F off and go use whatever the heck you use for Node, because who develops on Windows anymore? Here we can see that uglify.js depends on npm, and then we actually install the uglify.js from GitHub, since there were some awesome error checking features that they didn't have out on npm yet. It was terrible. It's like, oh, there was a parsing error. Not going to tell you where. Thanks. I know you know where the error is because you just parsed the thing. And here's where we actually have our real targets. So these are the targets that are not phony. So these actually produce files. You can see that the Jive.js target, we define Jive.js up here, right? So this just allows it to be easily changed which file you're looking for. Actually depends on all of these Jive.js dependencies, and it also depends on the uglify.js package being installed, at which point we then call uglify.js with any flags that we have defined. The output is our Jive.js, which I could replace with this. I don't know why I haven't yet. We also output a source map, so that way when you have debugging in Chrome or something like that, it takes the unminified versions basically and shows that to you, so that way you can debug a lot more easily. And then we pass it all of our dependencies, so that way it takes all of our different files, munges it into the single one. Here, just kind of some basic ones. Build depends on Jive.js, since you have to give it a file that you actually want to make. Clean removes the Jive.js file. We have tests. The tests run the Jasmine node command with the spec directory as its option. And then if you want to test things in a browser, we do serve for the current directory, so that way you can browse to like index.html or whatever in the test folder and run the tests in there. And then, yeah.
Sorry, I was just wondering, now maybe I didn't understand you earlier, but so I haven't seen anything like this since I've done C++ before, especially now with JavaScript. So why did you guys decide to use something like this, and what were the advantages of it, and why did you guys kind of do it?
Over other code systems, or
Yeah.
over like Grunt can do your minification and your J templates to make your copy and such. Grunt can definitely not, SSH into a server and tell it to install Node and put Node on uptime, and So we plan heavily on using this for more than just minification technical files, and as such, Make has just more power to it than Grunt. We could, if we wanted to, have Make just call a Grunt script for the minification part, but then we have to teach all the new developers two different build processes instead of just one file. More for that. We've got, also like you mentioned, we're going to be compiling all these into different distributables that can be installed, and Grunt can definitely not do that. Grunt tried self-asleep if you tried to have it run a Chromium build and then wrap it in an application wrapper, and then deploy that to your TLC or FTP server for customers to download. So makes just a bit more robust and low level, but at that you see that we're doing something a little bit more low level than just saying let's make a file.
Okay. So can you run then? So you'd still be able to just like run like a preprocessor if you want to do code description before
Yep.
and then just do the whole process.
Exactly, yeah. So just like we have like this uglify.js, another thing you do is like call Coffee or Jade or whatever and have that preprocessor take those files, munge them into a different file.
Show them afterwards later, show them the main OSCE
Yeah.
file.
I have, in the not public repo, I have a lot more advanced make file that does a little bit more crazy stuff, including taking some Jades, munging those. We have a project that we call Bundle Man that takes the different modules that we have and actually compiles them into kind of one big closure, so that way you don't have to worry about wrapping your code in a closure and doing all that stuff. Yeah.
There, a lot of your dependencies you're listing in there is the reason you are requiring npm. The reason you don't want to use npm built
We do in some places, like a lot of the places we have like, cd into a directory and run npm install. I don't know why we didn't do that on this one. We could. Haven't yet, I guess.
Follow us.
Yeah.
What do you guys use for your CI monitoring? Use like Jenkins or Anthill?
Right now, the question is, what are we using for our continuous integration? Right now we're using Jenkins, mostly because we have a bunch of Java guys that already use Jenkins, so why go with something new if we already have something that usually works?
Our Jenkins build is way slicker than theirs.
Yes, it's true.
Literally runs make tests.
Yeah. So, yeah, question in the back.
Does this also replace Puppet or any shops and stuff like that?
Probably you wouldn't want it to. It's not very well tuned for that kind of stuff. I mean, you could probably hack it together, but I kind of wouldn't recommend it.
Puppet and Chef lets you go for the bare metal on
Yeah. This, you,
some OS running. Yeah.
exactly, yeah, so.
Sorry, so you said this will SSH into a server and install stuff, so.
You can have it do that, yeah. So we actually have our continuous integration doing the SSHing into and then running like make install, at which point it installs all the different dependencies, copies configuration files to where they need to be, all that great stuff. We don't have it SSHing into the box itself. We have our continuous integration do that. You could do it since these are just like bash commands. You could just tell it, SSH into a host with this command or whatever. So.
Right now the Jenkins flow is, it SSHs into the box. It does the git checkout of the stable package, just pass testing, and then it runs, make run or make install depending on it. Just for ease, honestly. The beauty of make is it could do it all using make, but Jenkins already has pretty solid SSHing abilities, so why not?
Yeah. Anything else about the make file? Awesome. So now I'll focus a little bit on the tests here. As you can see, we have this spec directory. This spec directory has, surprisingly, all of our spec files. So you can see that it's pretty much one-to-one on the cap spec. Each of our different libraries that we compile code or take and munge from the different files into one file. We have a spec for each one of those. The different specs look a little bit, let's go ahead and do like, I don't know which one I want to do. We'll go with map, I guess. Actually, I know capped better and could probably explain it more easily. So capped is basically a capped array, so an array of size 20, and if you hit more than 20, it basically tells you either, hey, you're over 20, F off, or hey, you're over 20, I'm going to like revert back to the first one and just start overwriting from the beginning, kind of like a circular array. So here we have our tests. We're using Jasmine currently. Might rewrite these in Mocha or something someday, but they work, so why take the time to rewrite them right now? We check to make sure that we have a underscore capped that is not undefined and that it is an object or truthy, I guess, to make sure that when we import this file that we actually have a capped array that we can make a use of. Here we create a new capped array, add a bunch of things onto it, check to make sure that, hey, because we created capped array without rotate, the length is exactly 1,000. The first, I guess by default it is rotate. We have 1,000 entries in there. The first one is 5 since it started over the beginning, and the last one is 1,004. Here we create a new one with size 50 and rotate false. We stick a bunch of stuff on it, and then we can see that the first one is indeed 0 and the last one's 49. I'm guessing most of you guys are pretty familiar with unit tests in general. You can do some pretty cool stuff with Jasmine, including spies. It's got a whole bunch of features. It's pretty awesome, actually. Any questions regarding unit tests? Yeah?
So when it comes to unit testing front-end design and development, my biggest problem comes to conceptualizing. How do I say, like, I'm going to test to make sure that this button, when it's clicked, will scroll you to the bottom of the page?
I would argue that's more what integration level tests are for, so doing things with like Selenium or Casper.js. I would say that unit tests should not be done or used for that. you know,
If so, you'd want to segment perhaps better, right? You would test that this button when clicked, it calls this function, which
Right.
is spying on because I don't actually have a browser that's actually going to do anything right now, but it totally called the button was clicked function and passed it some parameters, right? So you end up imposing essentially contract breakpoints and then being able to then treat each unit as a black box unit. But yeah, if you actually have to see it scroll, Selenium, Casper, if you don't care about anything aside from like tip WebKit and Casper, then your life will be better. But if you have to tell other brothers, Selenium's really your go-to for now.
yeah. Yeah, so any other questions on unit testing?
Yes, this caps polyfill is awesome.
Yeah. We actually have some really cool stuff in here. Not all of it's documented perfectly yet. We're currently working on that, but it's pretty good. Yeah, back.
Is spying like getting access to private functions that you need to test? Like
Well, so since it's JavaScript, and if you have actual private variables that, you know, you have a closure and that variable is declared within that closure, there's literally no way to access that variable since it's truly private. No one can really get to it. So what spies generally do is they kind of act as a middleman for the function and generally like wrap it. So you can use a spy to see that the function got called with the right parameters, and then you can like give it different parameters, give the actual function different parameters. You can check that the return was correct. You can check how many times the function was called, different things like that. But private variables are actually private in JavaScript if you do it right.
This
Yeah.
was, what, a month of what the hell is the matter with our tests?
Yeah.
Our core lower-level libraries, the ones that we've taken the pains to have a lot of private logic, you know, encapsulated. A lot of times you'll see people do it sloppy with the underscore convention, right? We have some that we really can't expose some of the internals of, so they're truly private. You have to go to see it, but there is a is global debug mode true check at the very bottom of most of the constructors, at which point what it does there is actually exposes a bunch of fakey underscores in case you want to get at them, and it exposes a bunch of private variables in case you want to expect them. And that is something that our dev flag and make will kind of trigger that to be set when you run it, so you can inspect, because otherwise you literally cannot. You cannot spy on the private methods or properties of objects.
So, follow up to that. You're saying, for the most part, you have to set up your own system in the production code to a certain degree, in your actual logic code.
We rip it out. In the prod build, it's not actually in there, so someone can't just go to console and be like, set debug mode true, because then no one is listening for it. But yeah, if you want to be able to test and actually spy on private variables and methods that are inside a closure and actually do a GeoOp, you have to expose them out of the closure. So the only way to do that is usually at the end of the closure, either, you know, not retard debug mode, expose just the stuff that's safe, or retard debug mode to expose everything, right? So it makes it so you can't actually spy test on your actual prod code unless you want to be doing that for vulnerability. So that's a logic.
Yeah.
Why are you worried about making some of your methods and variables private if you open source the code?
Oh,
It-
the code
it's-
that does that's definitely not the open source code.
Yeah. And it's, you could always, you know, go and look at the sources tab inside of the Chrome developer tools and see the source, right? So it's not the source code that we're trying to protect. It's that we want our code to be third-party safe and to, you know, have all of the reasons that you have private members and methods, because you don't want people messing with them.
Accidentally use the same variable name and
So
who knows what happens.
we're making an application UI that can allow third-party modules to participate in the ecosystem as long as they fulfill, and we're actually jailing them in workers, and we've got some things so it's not like normal JavaScript where, well, you included jQuery, so you're bugging. So for that point, yeah, if someone is smart enough to throw a debugger and open up dev tools, we can stop them. But if they're smart enough to do that, not people that, I mean, they could already do that and just destroy our code anyway by setting everything to null. So this is to keep the third-party ecosystem safe so that they cannot, for the life of them, actually muck up in the internals of the application system.
Right.
Because they are internal.
And you see, you have a debug version, and then you rip out those when you put it in prod. How is that part of the build process?
So the bundle man thing that I talked about earlier, he rips out some of the different things. So he just looks for different patterns or whatnot. Yeah. Next level up or down, depending on how you look at it.
It's a Java and .NET type framework or we've implemented that in JavaScript. And you write a bundle, you have to provide certain pieces, a manifest, an activator, core internal classes, etc. You provide those as concrete individual files. Bundle Man's a project that Jeff wrote that command line NVM make takes those, sanitizes them, checks them, builds them into a concrete single file for that bundle, and it can do different things based on which environment it's building it for. So he's the guy that sanitizes and jails it, and even if you try to be a jerk, you can't really bust out of your closure because Bundle Man's going to have another one around you anyway. So.
And overrides things like self, this, global, window, to try to help make things more third-party safe.
Anyway, so you can't replace window or
Yeah. Any other questions?
We can show you some of those other build scripts.
Yeah.
They're just not open source. So
Correct.
photograph in memory, you're not really going to have too much luck trying to figure out what it's supposed to do without an understanding of those directly.
So,
You might have to close your eyes. No, we're in the process of commenting and ripping out our domain proprietary stuff because the UtahJS shit is actually just without a call.
actually, I should do a Git Pull. We did an update earlier today.
We did it like 6 months ago, so we'll probably send them an email. Here it is.
Yeah.
That's taking a bit of sanitization, and I got my boss to sign off on spitting it out for free.
So I just did a poll, got some updates, so now I can run like make. Oh, because UtahJS was in the repo, so it's already up to date. We're good. And I can run make test, and it will actually run our tests. As you can see there, apparently Nick left some console logs in our tests.
I'll blame Dan.
All right, fair enough. And we can also run make test browser. It'll start up a server serving for this, so that way I can open it up inside of a browser. Localhost 3000. Go to the spec directory, and here we can see all of our different tests running, and everything's good. So that way we can open them up in Selenium, make sure that they work on all of the different browsers, all that great stuff. So this brings us to our final step in the continuous deployment process, which I just realized I might actually be able to access from here without our VPN. Yeah. So I'll just tell you guys about it instead. Specifically, kind of what would happen. I can show you Theo's Revenge. So kind of the general process that happens is we do a git push, gets to GitHub. We have a Jenkins hook plugin that hooks into the git post commit hooks. So as soon as we push something to GitHub, Jenkins is like, oh, something new happened. I better rebuild and check and test and deploy and all that great stuff. At which point it SSHs into our test machine, right? So we have a test environment that's totally separate from the production one, so that way if test gets broken, the production doesn't get broken, we can run tests on it, all that great stuff. So once it gets there, it basically does a make clean, removes the build directory, then does a make install, which won't work right on my Mac because it tries to do things like install Nginx and whatnot. So if I just run make run, it'll do essentially the same thing. So you can see here, we're munging a bunch of different files. We're taking the stuff in the design directory that our UI and UX people actually touch. They don't touch the other stuff because we don't quite trust them with some of that stuff. But the design directory with the CSS, or less, I guess, and Jade's, they muck around in there all the time. We install the different NPM dependencies using npm install, like I said earlier. Twiddle our thumbs for a moment while this compiles.
You guys added this one. This one's verbose.
Yeah, a little. But it does some pretty cool stuff, so. And it's fast. So.
On average, how often do you deploy?
To our test server, we deploy like 5-10 times a day, I bet. Because the business has decided that they actually want to, push the button before we deploy to production, we generally deploy after each agile sprint, so about once every 2 weeks.
There's nothing technically holding you back from deploying.
We had it deploying every single time the test passed.
We had to roll that back to a more manual push button gate.
So jealous of your process.
Interesting. Apparently I have some changes locally that I broke and didn't test earlier. Oh, you did?
Yeah,
terrible console logs and all sorts of stuff. Probably a dangling comma. I could fix that real quick, I guess.
So you guys' machines are manually set up with nodes and stuff in the first place.
The only dependency is brew. If you have brew, we can install everything else, and literally all you have to do is do a git clone and then a make. Oh yeah, and make. And OSX is a piece of crap, and you have to have Xcode in order to have make. But with make,
The servers have an AMI that we configured some, because our servers have a lot of VPN and interesting things going on.
that
So,
was
but
the
really only thing they have to have
entity.
built is make, because on the server, what James will call is literally just make.
Hello.
And from there, it'll
There you
handle
go.
getting Yum, getting Mongo, turning uptime on Mongo so the server can stuff to restart it.
How long do those builds take? Because to me, it sounds like nodes takes forever to install.
Oh, and I already have a server running, of course.
We run copies of NPM and a lot of the repos as well for Yum, so we keep fresh copies. So perhaps that's why we don't realize it. For us to run the full Selenium suite, which runs through the full suite twice, once on test and once on prod, usually takes, I think it's up to like 30 minutes now, but it's running something like
Oh, hey, there you are.
Selenium UIs, which require SoftLabs to spin up a server. I mean, so SoftLabs is the whole right there.
So the make process generally takes about 2-3 minutes generally, including like installing all the dependencies and all that great stuff. So I just did a clean, and I'm starting over basically from scratch here.
Do you have a server running in another?
I did, and then I killed it. So
That's the stupidest node error in the world. If you're ever getting this random ass error that doesn't say anything to you,
it says error address in use. Like, how much more descriptive could you be than address in
mine
use?
just spits at me that there's an error
No.
somewhere deep in the internals that
Mine tells me error was in or address was in use. So.
-9 nodes.
So this module takes kind of a little while, magic or whatever.
You did a clean.
Yeah, I did.
So
So generally, since make has like file dependencies built in, it will only remake the files that actually need to be remade. So if you only changed one file, it will only change the files that depend on that file, or only remake those. So generally, remaking after changing a bunch of files takes like 5 seconds. And I just have this thing called make watch going in on the background that automatically runs make like every second or so. So you can see that server started up now. I have a tab open, and since it got disconnected from the server came back. It's like, oh, better connect. So that's what all this is about. But yeah, literally getting things running for our project is as easy as like make run, and it will do everything else. So. Any other questions? I got like 10 minutes left, so yeah.
How long did it take you guys to kind of lock down this process to get everyone on board? I don't know what your
So our specific team, that we're the only ones there that have all of this system implemented right now. We're kind of on the leading edge for our company for this.
I got a mandate from the CTO and I just did it.
Yeah. So it was like a 3-4 person team, and Jeff did a lot of it. He did a lot of the Jenkins stuff and the make files. He's not on our team anymore. He got swapped, but which
So we
we're
had,
sad
like,
about.
Immediate buy-in, and the process was up and running in 2-3 weeks.
Yeah, it was like 2 sprints, 2 to 3 weeks, maybe a month tops, including tweaks for the business wanted it to be push button instead of whatever, things like that. But it was about a month. Yeah.
So did that time include writing all the tests, or tests were done?
The tests we write as we get our stories. So
Tests were already done.
yeah, all of the tests were done. So yeah.
The Selenium part wasn't used, but
Why don't you speak to that, Jeff? I know that you learned make in like a weekend.
It was a few hours on a Saturday.
you also commit to salt though, so obscure randomness is your lifeblood.
I was bored one Saturday, so I spent 3 or 4 hours and became an expert in make.
There's actually some really great resources for things like Make. Since it's literally been out since 1977, there's documentation like you wouldn't believe. So yeah, up front.
It's a little bit off topic, but I heard you talking about the end of your sprint. I wanted to know what tools you use to manage your sprints on your team.
Right now, we are using Pivotal Tracker. It's a little rigid, but other than that, it's pretty good. Like, for example, this past Thanksgiving, 2-week sprint, we had like 3 or 4 days instead of, 10 working days. And it still wanted us to do a full 50-point sprint instead of, 25 like we should have done. Other than that, it's really good.
Yeah, but it's like I can change it. It's like, oh look, I'm gonna show it to you as if it was 50. It didn't actually change the internal. As soon as someone else logs in, it's still gonna like yell at them that they're behind on the sprint.
Yeah.
Well, that's okay.
I'm trying to see if I have a copy of the source for the previous company I worked at that we wrote our own, which is pretty freaking slick, but it's unlikely.
How would you compare it with other common tools like Jira or AgileZone?
It's a lot more lightweight, a lot more opinionated. It works pretty well. It doesn't have things like time tracking. I don't think it has integration with like GitHub or source control in general. Other than that, it's really great. So we use it a lot for like planning, putting stuff in our backlog and Icebox, tasking things out, pointing them, all the general kind of agile Scrum type steps.
We replaced
So
the spreadsheet with the product owner was trying to make us use.
yeah,
That's a win.
yes. Anything other than a spreadsheet or sticky notes on a whiteboard is well worth its weight in gold, in my opinion. So, anything else?
So Pong request means ping me?
Ping pong, ping pong.
Yeah. So we use WebSockets, so occasionally it'll just kind of send a keep alive, as well as we send a little bit of information like what, for analytics, are there any errors on the page, things like that. So.
Yeah, the pongs we take advantage of the keep alive pong to actually send up
A little bit of data.
what
Just,
Google Analytics would give you.
yeah.
Reinstall for it?
Yeah. So if I just like touch one of these files, so if I touch like, let's see here, if I touch server, routes, auth, and then run make, you can see that it basically just copied the auth into the new build, and that was it, really. So, it can be really quick when you don't have to install everything, and by default it doesn't, just when you run a make clean, basically. So,
How often does the install rate that part of the
once,
that's part of the
yeah.
That's part of the make install, which you really never run after you've installed.
Yeah, so once the dependencies are installed, you're pretty much good, unless you like nuke your machine, but you'd be reinstalling dependencies anyway.
So like we just had a new guy come on. It was literally a git checkout make install. I mean, he had already done some of the brew Xcode Mavericks things and everything that Mavericks wrote. But for example, the designer, we had a new project that we just ramped up, and
He walks over, so I need you guys to come help me get this set up. And we're like, git clone, make run.
never one step, and it was one step.
It doesn't take a day to spin up anything.
No, definitely not. Like,
The designer guy, like, here's your new project, touch the J files and less files and don't touch anything else. Here's a git ignore that will help you.
so for example, originally we actually had Jenkins create a brand new Amazon instance every time we did a commit for testing. Amazon took a little while to like actually provision it, but once it was provisioned, it took like 5-ish minutes to install everything, get it running, and have the test start running. So from bare metal, 5-ish minutes, give or take. It's pretty responsive, not a big deal.
Nginx in front of node with the Nginx comp files
Per environment,
It has
right.
different comp files that are set up and then different node deployments in Mongo and et cetera.
M1 medium, M1 small, something like that. Our production-ish early alpha is an M1 large, I want to say. So,
180 now?
yeah, 180.
In Office?
Yeah.
50 some odd extra.
I've been in a couple of medium-sized companies, and it was a good day if you just get spun up in a day.
So the fun part is the CTO me, right?
Yeah.
He's got a real flat structure going on.
Yeah. So we're hiring. If anybody wants to come and help make awesome things, this is the kind of stuff that we do. We make awesome tools and we make use of awesome tools. So.
And as you saw from the Git commit, our promise library is more compliant than Q.
And it's faster.
So,
Not that we're bragging.
There's that.
you're pretty much out of time.
Yep.